what do we have? We have two links connecting these two switches together. We are not using Ether channel right now. Therefore, they're not bundled together, and Spanning Tree Protocol will see these as two completely separate links. And as a result, one of these links have to be blocked to prevent a loop from occurring within the spanning tree instance. By default, the cost is tied because they are the exact same bandwidth. Therefore, they have the exact same cost. When the BPDUs are sent out of the interfaces, they will have the same bridge ID. Why? Because they're coming from the exact same switch. The priority is the same, the MAC address is the same. Therefore, it is now the port ID that has to be examined because the cost and the bridge ID are tied. So just like with Spanning Tree Protocol and Rapid Spanning Tree Protocol, all of our interfaces participating in Spanning Tree are going to have a port ID associated with them. And we can see that in this output here under the prio.nbr, so priority number column. By default, they're all going to have a value of 128 dot something. So what is the dot something? It's a number that's assigned to the interface by the switch, and it cannot be changed. So in this case, the 3, the 4, the 5, the 6 cannot be changed. It's hard-coded for that particular interface. Typically, the lower speed switch interfaces are numbered first. So let's say we have fast Ethernet and gigabit Ethernet ports. The fast Ethernet ports are numbered first from 1 to however many fast Ethernet ports on the switch. So if we have a 24-port fast Ethernet switch, we get numbers 128.1 through 128.24, and then any gigabit Ethernet ports after that would get 128.25, 128.26, and so on and so forth. We can't manipulate these values, as I've mentioned, but we can manipulate this value here, the priority number. And by manipulating the priority number, we can now influence which link will be blocked in this case. However, this priority and this port ID value is only going to be examined when we have a scenario as we see here, the dual links between two switches. We can see that in this topology here. Gigabit 1/0/5 and 1/0/6 are links between DSW1 and DSW2. And right now, if we go to DSW1 and we examine the output of show spanning tree MST2, we can see here that gigabit 1/0/5 is the root port going over to DSW2, which is the root bridge. We need to influence this. We want gigabit 1/0/6 to be the root port. But we are not allowed to change the cost on DSW1. So if we can't change the cost on DSW1, what can we do? Well, we can influence DSW1's decision by changing the port ID, that priority, on DSW2's interfaces. That way there, when the BPDUs are sent and they're analyzed by DSW1, it will choose the BPDU that arrived in on the interface with the lower port ID because cost is tied, bridge ID is tied, therefore port ID is checked. So let's go to DSW2 and we will go to interface gigabit 1/0/5. So interface gigabit 1/0/5. Notice that for DSW1 it's currently the root port. So since it's currently the root port and it's 128.5, in order to make gig 106 the root port, we have to make sure that when the BPDU is received inbound from DSW2, it has a value that is lower than what it's receiving from gigabit 1/0/5 and DSW2. So let's analyze DSW2's port IDs right now. Do show spanning tree MST2. Right now, gigabit 1/0/5 is sending 128.5. And 1/0/6 is sending 128.6. So let's make 1/0/6 have a lower port ID. Interface gigabit Ethernet 1/0/6. And we'll say spanning tree MST2. What's the options here? Port priority. So let's take the port priority and lower it. Right now it's 128, we said. Let's change that to 120. Oops, 120. That didn't work. There we go, 120. It says I can't. I have to do it in increments of 16. All right, no problem. Let's just use 16 then for fun. So port priority 16. And now let's examine the output of show spanning tree MST2, and we can see that the port ID is 16.6 now in the BPDUs that are being sent out that interface. If we look at gigabit 1/0/5, the BPDUs will have 128.5. Which one's lower? Well, 16.6 is lower. So we can now anticipate that DSW1's root port will have changed. It will have changed from 105 over to 106 because the BPDUs coming in 106 on DSW1 are superior now. They are better. So if we look at the output of show spanning tree MST2 on DSW1, 106 is the root port now. But realize it did not change the priority on DSW1. It didn't touch those values. We only touched DSW2, and it was through the propagation of those BPDUs, the BPDUs that are being sent to DSW1, that DSW1 was able to make the change from having 105 the root port to 106 being the root port. So it's another way that we can manipulate the spanning tree topology and dictate which link will be utilized.